So, welcome back to Anand's Academy. So, I'll be teaching types of fatty acids. Okay, there are two types of fatty acid. They are saturated fatty acid and unsaturated fatty acid. Saturated fatty acid is a type of fatty acid which has only one double bond in the fatty acid. The example for the saturated fatty acid is palmitic acid and stearic acid. Where for an unsaturated fatty acid is a type of fatty acid which has one or more double bond in the fatty acid chain. Example for this is oleic acid and linoleic acid. So, I'll be teaching about saturated fatty acid in today's class. Okay. Now, I'll explain you transport of fatty acid to mitochondria. Okay, by palmitic acid. Okay. So, what is an structural formula and what is it? Okay, the palmitic acid is extracted from palm oil. It is extracted from palm oil. The molecular formula is C16H32O2 and structural formula is CH3 CH2 11 CH2 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 COO minus. This is a structural formula. Now I'll just tell you how this palmitic acid converts into palmitoyl-CoA. Okay, CH3 CH2 11 CH2 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 COO. This is a palmitic acid plus HS-CoA is an coenzyme. Okay, gives rise to CH3 CH2 11 CH2 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 C double bond O S CoA. This is an palmitoyl-CoA. There are exactly 5 steps, okay, involved in this to form an acetyl-CoA and methyl-CoA. Okay, the first step is oxidation takes place in the first step. Okay, you just write the structure like this only, the palmitoyl-CoA structure. Okay, if you write the palmitoyl-CoA structure, and this will give rise to, I'll just write, okay, palmitoyl-CoA. From here the reaction takes place, completely reaction. This gives rise to transenolase CH2 double bond CH2 CH double bond CH COOH. Here the double bond is taken place. This is transenol-CoA. The enzyme is, okay, here FAD plus gives rise to FADH2, where acyl-CoA dehydrogenase takes place, where the oxidation is for this. Okay, and the second step I'll just write here. Okay, the second step is hydration. Okay, what is meant by hydration? Removal of water minus H2O, where by using an enzyme hydratase. Okay, you got this. This was the first step, second and third. Sorry, first and second. I'll go on with the third step. That is, this gives rise to CH3 CH2 11 C H, H, C, H, H, CH2, C double bond O, S CoA. This is beta hydroxy palmitoyl CoA. Okay, this is an beta hydroxy palmitoyl CoA. This is a third step. Now, in the fourth step, oxidation takes place again. Okay, where NAD plus gives rise to NADH dot H plus by an enzyme acyl CoA dehydrogenase, where plus H2O takes place. Okay, you got this right? And it gives rise to, this is in fourth reaction, CH3, CH2, 11, C, H, H, C double bond O, CH2, C double bond O, S CoA. This can also be written as double bond O. Okay, this is beta keto palmitoyl CoA. And the final step, this was the third step, and the final is thiolysis. Okay, where fifth reaction takes place, CH3, CH2, 11, CH2, C double bond O, S CoA plus CH3, C double bond O, S CoA, where an enzyme is thiolase, where plus HS CoA takes place. This is called as Mistral CoA, and this is acetyl CoA. Okay, this completes your reaction, where here splitting takes place. Okay, this will become different and this will be different. This gives rise to Mistral CoA and this gives rise to acetyl CoA. This completes your transport of fatty acid into mitochondria by palmitic acid. Now I'll be telling about the energetics, okay, energetics of beta oxidation. This comes under beta oxidation by palmitic acid. Okay, now CH3, CH2, 11, CH2, 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 C double bond O, S CoA plus 7 FAD plus 7 H2O plus 7 NAD plus 7 HS CoA gives rise to 8 CH3 C double bond O CoA plus 7 FADH2 plus 7 NADH dot H plus. This reaction, this complete reaction takes place in Krebs cycle. Krebs cycle. Okay, you got this. So I'll just tell you how much ATPs each molecule gives. Okay, this one, 8 CH3 C double bond O, S CoA gives rise to 8 into 12 is 96 ATP, that is through an TCA cycle. Now 7 FADH2 gives rise to 7 into 2 is 14 ATP by ETC cycle. Okay, 7 NADH dot H plus gives rise to 7 into 3 is equal to 21 ATP by ETC cycle. The total molecules is 131 ATPs, the total number of molecules by these cycles. Now for the 1 ATP for activation of fatty acid, 1 ATP on hydrolysis gives rise to AMP plus Pi, 2Pi, that is an inorganic phosphate, okay. This is an inorganic phosphate, I'll write as PO4, okay, which is equivalent to 2 ADPs, okay. Now, therefore, 131 ATPs minus 2 ATP gives rise to, this you got it right, gives rise to 129 ATP. Therefore, 1 mole of palmitic acid after beta oxidation is 129 ATPs. Now, 1 ATP on hydrolysis gives rise to minus 7.3 kilocalorie. Now we have to find 129 ATP on hydrolysis gives how much? Therefore, 129 into minus 7.3 gives rise to minus 941.7 kilocalorie. Okay, this 1 mole of palmitic acid gives rise to minus 941.7 kilocalories. Now I'll tell about the efficiency. Now I'll explain about the efficiency. 1 mole of palmitic acid, the standard free energy is denoted as delta G naught is equal to minus 2340 kilocalorie. This is in standard free energy state. Okay. Now we have to find the efficiency of beta oxidation is equal to minus 94. We'll consider it as, we'll round figure it and consider as 942. Okay, minus 942, because this is greater than 7, greater than 5, so you can consider it as 2. So 942 minus free energy state minus 2340 into 100 gives rise to 40%.2. Okay, this completes your activation of beta oxidation by fatty acids and efficiency. So today in this class you have learned transport of fatty acid to mitochondria by palmitic acid, then energetics of beta oxidation by palmitic acid, and efficiency of beta oxidation by palmitic acid. So if you like this video, please like, share and comment. Do subscribe, and there is a bell icon, please click on that. Okay, thank you, have a great day.